Hi everyone, I'm Isha and I have with me John and Anant. We are MS in Business Analytics students at Purdue University, and today we present you Flight Planner, an app that accurately predicts the probability of flight delay so that you can make informed travel decisions. Now, we've all been in a situation where we are stuck at the airport for hours because our flight has been delayed. This not only leads to professional and personal discomfort and wastage of our valuable time, but also leads to an economic loss of $16 million to the US economy per year. Aiming to reduce the frustration associated with flight delays, we developed an app which takes some inputs from the user and outputs the probability of flight being delayed. You can then try different combinations of inputs and compare your flights with other flights so that you can plan your travel accordingly. In order to incorporate our vision, we saw this problem from an analytical lens, and we identified certain factors that had a strong relationship with the probability of delay. These came to a month, day, and time of the flight, the duration of the flight, the departure and arrival cities, the distance between the two cities, and the airline company. Next, we formulated this as a classification problem, which means that the output will be either the flight being delayed or not. And subsequently, we will also get the probabilities associated with each flight being delayed. I will now invite John to take you through the detailed model behind our app.
So thank you, Isha. So let me start with the data, the methodology, and the model. So for the data set, our main data set was taken from the Bureau of Transportation Statistics of the US government, basically the flights data. And it had all the flights that are operating within the US. And we thought that the features in that app, we thought that the features in that Excel file would not be sufficient. So we incorporated other Excel files or data, such as the US Census data and also the airport database. The US Census data had a lot of extra features, such as the population of cities, the population of states, and the airport database had a lot of features, such as the location of the airport, the latitude and longitude, etc. Now let's look at the methodology. So as Isha already explained, we actually defined a classification problem, and we categorized every flight that were delayed by over 15 minutes as delayed. So the reason why we chose 15 minutes was because 15 minutes is a standard for a flight to be considered as delayed in the United States. Now, for the next thing, the database that we had almost 6.5 million records. So it was computationally very challenging to perform an analysis on all of that. So what we did is we thought we could take the top 30 cities by airport traffic for our analysis. So once we started our analysis with the exploratory data analysis, and through that we found that if you look at the flight delay, the average flight delay was varying drastically across the aircraft carriers, across the months, and across the cities and states, etc. So this aided as a catalyst in our feature engineering. So this helped us define a lot of new extra variables which we thought would be really useful while running the model. So for that, we defined extra columns such as the flight ratings, airport quality, the city bins. We divided the city based on the population. And on top of this, another interesting variable that we added was the holidays. That is, if a flight is scheduled on a national holiday, that would be ticked as 1 or 0. So that was basically a binary variable. So since we had a lot of numerical features and the magnitude of variation within these features were very high, we actually standardized all the numerical features using the Z-score standardization. And on top of that, since we had again a lot of numerical features, we did a four cluster using k-means. And the way we arrived at the number 4 was through our outputs of silhouette plot. And on top of that, we specified a 3-fold cross-validation method. So now, if you look at the models trained, we trained 3 models. First was Naive Bayes, logistic regression, and random forest. So among all the 3 models that were trained, we saw that the results were very consistent and good for the random forest model. So we went ahead and employed that for our analysis. And we could see that the error rate of random forest was 18%, which was the lowest among all the 3 models. Now let us look at what are the constraints or the challenges and what is the future scope of our analysis. So the biggest constraint was while developing the Shiny app, the issue was there were a few there were a few factor variables which were quite useful in predicting the flight delay. So we were somehow unable to incorporate those factors into the Shiny app model. So the way we overcame that was to convert all those factors into numerical features. Again, the main factors that we identified that contributed to the model were the flight carrier, the departure and the arrival city, day of week such as Monday, Tuesday, Wednesday, etc. So again, we used a lot of other columns such as the population, average delay, the total number of flights that has been operated by a carrier, etc. to convert these categorical features into numerical features. But another issue with this was that this reduced the overall accuracy of the model by a small percentage. Now let's look at the future scope of our model. We did not incorporate any weather conditions, which we plan to incorporate in the future. So weather conditions means a lot of variables such as the wind speed, the temperature, how is the day, that is the day rainy, sunny or snow, etc. would be incorporated to the model. And on top of the weather conditions, we also plan to incorporate the aircraft details, such as the make and model of the aircraft, how old is the aircraft, what is the seating capacity of the aircraft, etc. And we plan to incorporate all this in our future, in our next application. Now I request Anant to explain the functionality of the app.
Thank you, John. Now moving on to the Shiny app. So the reason why we are using Shiny app is it is a very user-friendly interface. So anyone with a link can use the app, and so the R is a very powerful analytical tool, and the Shiny app helps get a very beautiful GUI. So that is the reason why we are using a Shiny app. So anyone with a link anantgupta.shinyapps.io/flight planner can open this GUI, can open this app. So coming to the packages we found very useful were Caret, Random Forest and dplyr, which were used for building the models, and of course Shiny and Shiny Dashboard, which were used for building the Shiny app. So here we have a DSS for the Shiny app, and this is a dashboard for the flight planner, and we have 3 pages in our dashboard: authors, about and prediction. So we have authors Isha, Akash, John and myself. Coming to the about section, so as Isha discussed earlier, we have so the reason for making this app is because flight delay causes 16 billion loss to passengers worldwide in the US. So that is the main motivation for you building this app. Now coming to the third page, which is the prediction model. So we have all these input parameters, and this is our output parameter, the probability of delay of your flight. So in the input parameters, we have 3 sections. First is which city are you traveling to. So if you have a list of cities, so you can choose from Seattle, and then which city are you going to, which is your arrival city. So you can choose Dallas. So you have your departure and arrival city. Then you can select which airline do you want to go in, Southwest, suppose. And then moving on to the second section, when is your flight? So suppose you want to travel in November, and the date of your flight is 20th. And then what day is this? So is it a Saturday or a Sunday or Monday? So it's Saturday. So now moving on to the third section, what are your flight details? Now you need to enter the departure time in 24-hour format. So suppose your flight is at 1:45 p.m. So you just enter 13:45, and then choose the travel distance between Seattle and Dallas. So suppose it's 1,437 miles, and what is your travel time in minutes? 370. So based on these 3 blocks of inputs, city of travel, when is your flight, and what are your flight details, you'll get a probability of delay which is 0.32. So that is 32%. So there is a 32% chance that your flight will be delayed. So this, so you can now vary various parameters. Like suppose this is giving you a high probability. So maybe you want to change the carrier to some other carrier, maybe Delta. So Delta, if you change the carrier, it gives you a lower probability. That is 0.296. So all conditions being constant, you may want to choose Delta. And suppose you want to reschedule a flight to maybe March next year, and the date is 11th and the corresponding day is Wednesday. So you can get the corresponding probability. So you can basically play around with all the inputs and you'll get a probability of delay. So that's about the app. So in our next version of Flight Planner, which is Flight Planner 2.0, we plan to include a map which will show the origin city and your destination city, and it will have more advanced graphics and a better accuracy. So we assure you that you will find this app really useful, and we hope that you include it in your list of commonly used apps and you recommend it to your friends and family. Thank you.